In this interview, we get expert tips on speeding up our web apps, and we talk about important things to know about HTTP 2. Hey fellow developers, and welcome to the Scale Your Code show. My name is Christoph Limpeler, and today's guest is Ilya Grigorik. Now, Ilya is a web performance engineer at Google, and he's also the co-chair of the W3C Web Performance Working Group, which is a mouthful, but saying that he's an expert on web performance is certainly no exaggeration. I would also like to thank Linux Academy for sponsoring this episode. If you're interested in learning more about AWS, Linux, DevOps, or even OpenStack, then I've got a really good deal for you. Go to scaleyourcode.com/Linux Academy and get a 24% discount. This is a really good deal because these are high quality training videos and also hands-on labs. So grab it while you can. Ilya, welcome to Scale Your Code.
Thanks, Christoph. Thanks for having me on the show.
So to be perfectly honest with you, I hold you partially accountable for the start of this show. And here's why. Just a few years back, I was just working on this web app, and I remember it loading like it took 5 or 7 seconds to load the page. So you couldn't see anything, you had a blank screen. 5 to 7 seconds later, you had the screen. And it was so infuriating, but I didn't understand why that was happening. I didn't get that certain things happened that blocked the rendering, etc. So I did what most people do. I went to Google and I started typing, why is my website slow, right? And of course, one of your videos popped up. Now, this was a few years back, so I think you were talking about Speedy at a conference. You were talking about how the bytes transfer over the wire, why latency is so important, and all kinds of topics like that, which really piqued my interest. So before that, I really didn't understand that was how the core internet worked. But once I heard about it, I was really hooked with it. So like I said, I hold you partially responsible. But I think that's a good thing, so thanks a lot. But anyway, so what I really want to do with this interview is kind of go back to what inspired me so much with that first video, and that is getting a better understanding of, first of all, how web pages are created, and then second of all, how the bytes transfer over the wire, how that affects the performance, that sort of thing. So I know you've also put out a lot of content concerning this information. So if people have questions after this, or if they want to learn more, then I will do my best to link up as many articles as I can so that they can follow up with your content and learn more that way. How's that sound to you, Ilya?
Sounds great.
Perfect. So let's get started by first asking a little bit more about what you're doing as a web performance engineer at Google, and also the co-chair of W3C Web Performance Working Group.
Sure. So my day-to-day, job at Google is both as a developer advocate and performance engineer. So I work with both internal teams within Google, various products, and also external developers trying to understand what pieces in the web platform that we have today are missing. If they're not missing, then what are the APIs that we can make better, and how can we make the browser itself just better for kind of a wide variety of use cases. And of course, in a more recent time, mobile has become a very big thing, as I'm sure everybody realizes. And so there's a lot of focus on how do we optimize the browser and the browsing experience and the web pages for mobile environments, which there's the size in terms of being responsive and all the rest, and also the performance. So we are seeing, as developers, we have to work with a very wide gamut of devices and connection types. So the slowest devices that some users are using, and there's actually a huge number of users that are accessing the web in these slow devices, are slower than dial-up than we had a decade ago, right? Which is remarkable and sad, but that's what it is. Like there's just many users coming online that are completely new to the web, and that's the experience they get. So when they try to load one of our web pages, it takes a while, and where a while is like minutes, and it seems completely ridiculous. And we're trying to figure out how do we fix that? What do we need to do to enable on the web platform and elsewhere to make this actually work?
And I've got a decent internet connection, and sometimes I'll go to websites and it still takes a few seconds to load anything. So I can't even imagine being on an extremely slow network with mobile, how slow it might be to load some of those pages. But when it comes to understanding these wide ranges of needs for the entire internet, really. How do you get the information from all kinds of different people? How do you get different people to help you communicate or communicate to you and help you figure out what goals are important and that sort of thing?
Yeah, so there's a couple of different themes in there. So the way the network, when we develop our web apps, let me start there, right? Like we open the editor, we type in some angle brackets, we save it, we load it in the browser, and everything looks beautiful and everything is fast because everything comes off your local hard drive and everything's nice and smooth. Then we deploy it out into the wild, and users start interacting with our site, where user has to contact your server or your CDN or whatever, right? And there's a variety of different conditions there. And that's typically something that a lot of us miss. And you kind of mentioned this experience where you built the web page and then you tried to load it and it was taking a while. And I'm guessing that was because you finally tried to access it over like a real internet connection as opposed to locally. And that is the great abstraction that our networks provide, right? It doesn't matter if you're fetching it on a mobile phone over a wireless network, an LTE network versus a Wi-Fi versus something else. As developers, we don't have to think at that level, or we don't think at that level, until the point that we realize that something's gone really, really badly when we try to load it on one of these networks. And that's where you have to start digging in, and you have to get into this conversation about latency and why do we do the certain best practices that we do, why do we need things like HTTP2 and all the rest. You kind of like, you can go arbitrarily deep. Then there's another question you asked, which is like, how do you know when the experience is slow for the user, right? So it's one thing to open it on your local machine or test it on your connection, but what about the rest? And that's actually where the work that we do in the W3C Web Performance Working Group comes into play. Because one of the main goals for that group is to define APIs that allow you to gather performance data from out in the wild, from real users. So as opposed to, say, synthetic testing, where you run a benchmark or a test on your computer or some computer in the cloud or somewhere else, you can actually gather data for how long did this page take to load for users in India versus US versus Canada, and segment based on that. So that's what we've been focused on for a while. And it's different performance data, slightly different performance data than from what you used to say in developer tools. When you open developer tools locally, you get a very rich set of data in terms of stack traces and all the rest. The RUM, or we call it real user measurement data, is much higher level. So we'll give you things like the request took this long and the connection took this long to set up. We won't give you the same fidelity, but it's enough for you to at least directionally figure out that in certain markets, my pages are loading much slower. So then you can talk strategy. Like maybe it's a CDN, maybe you need to make your pages lighter, maybe it's something else.
So really the group, at least part of the responsibility is finding some of those tools or creating some of those tools, or even if the tools already exist, maybe refining them to match the current market. Is that right?
Yeah, so for the W3C group in particular, it's not that we're building the tools themselves as much as we're defining the APIs. So we need to define, let's say, a standard to measure frames per second, right? Such that you can gather data from out in the wild on whether your animations or scrolling is running at 60 frames per second.
I see.
Today, you can't really do that, at least not without many hacks that by themselves hurt performance.
Right.
So we want to provide a standard API that is easy for you to use, does not affect the performance of the browser in a negative way, and allows you to beacon that data back to then some tooling that you have on your servers, or maybe your analytics provider is gathering this data for you. And then you can process it, munge it, get a report and say, well, my loading is great in the US, but when users try to access it from Canada, they're seeing an extra 150 milliseconds of latency or worse.
So you could then go and say, well, maybe we need a CDN closer to that origin and measure that and see if that improves, et cetera, et cetera. So it's really very, very powerful and very useful tools, at least in measuring performance and that sort of thing. So hopefully we'll get to talk a little bit more about that. But first, I'm really curious to know if there's just one kind of of a problem that most people do that really slows down their pages. So for example, when my site was really slow to load, it was actually the hosting that I chose. I chose a really bad host. It was on a shared host platform, and it just took forever to give me an answer back. So all the time was really just waiting for that time to first byte, which we're also going to explain in just a second. But what's that biggest problem that people usually do that really slows down their pages? Is there one such thing?
Oh boy, I wish there was just one. There are many, and it really depends on your application. This is where telemetry comes in. This is why you need analytics to figure these things out, because it'll vary. In terms of the high-level kind of things that you should make sure that you get right, enabling things like compression, right? So I still see many sites that deliver their HTML, CSS, and JavaScript without enabling gzip, and that's a huge savings, data savings, in terms of how quickly the data will be delivered, and also reduces the amount of data that needs to be transferred, which can be very expensive for some users. There's things like optimizing images, right? So it is still unfortunately common to grab a photo off your phone or off your camera and just kind of drag it into your editor and be like, here, let's just resize it. And what you don't realize is that under the hood, it's still downloading that giant, whatever, 10 megapixel or 40 megapixel image, and then rescaling it on the client, which is very heavy. And in fact, we know that if you look at the pages, in terms of distribution of the size for different resources, images on the web today contribute to more than 50 to 60% of the total transferred bytes for pages. So optimizing images is a very big thing. Compression is a big thing. Depending on the protocol you run, like you may need to do things like concatenate files, although you don't need to do that with HTTP2. We'll talk about that probably at some point as well. So there's a lot. I would say, if you haven't already, check out PageSpeed Insights. So use your favorite search engine, search for PageSpeed Insights, and just type in your URL there. It'll run a couple of tests in the background, and it'll tell you kind of the biggest things that you can do to fix your particular web page.
Does that include the gzip? It can tell whether there's gzip enabled or not, whether you're serving images that are not compressed or are loading too much metadata that's completely useless and eating up too much bandwidth and things like that. Does that include all those measurements? Yeah, so actually what happens under the hood is you pass it a URL, and we actually fetch the page in two modes, via a mobile browser and a desktop version. And when we load the page, we look at, do all the resources have compression? Do they have caching enabled? Do they have cache lifetimes? For images, are those images compressed? If we actually try to recompress them on our end with our optimized compressors and see if we can get further savings. Also look at, is the image being displayed at the size that is being transferred? So coming back to that use case of like you ship a big image and then you scale it down to something small, right? So we check for that. There's a collection of different checks for other things in there as well. And the great thing about that report is it's relevant for your particular website. So you can kind of go in order and say, well, look, I forgot to enable compression or caching. Those are probably your biggest wins right off the bat, and then you can go into the tail and start optimizing other things. The previous interview right before you was with Kelly Sutton of Imagix, where we do cover image optimizations, and they explain how their service works and how it processes these images and compresses them, does all this magic, or it's not really magic, but does all these things to the images. So if you're interested, check that out. It's pretty interesting information, and it can really save a lot of bytes being transferred, which, as you said, is a very important thing to optimize. So as far as saving the number of bytes being transferred, is compression really the main thing you can do? What else could you do to really minimize how many bytes you transfer?
Don't ship things you don't need. So just download fewer stuff, right?
Right. So some pages download CSS file they don't even need for that specific page. Is that what you're talking or referring to?
That would be one example. Yeah. I can't tell you the number of pages that I look at where when we audit them with the actual developers, we ask, like, do you actually need this widget script or something else? And after some head scratching, we realized that was put there a couple of years ago, And it just stayed there
Yeah.
because nobody took the time to audit it. So even just removing literally unused content can save a lot of bytes. Making sure that you fetch the most optimized version of each asset. Right, so compression, removing redundant content from it, minification, so removing unnecessary data from within the file itself.
Hmm.
And then coming back to images, that is probably your biggest savings there. So making sure that you have that figured out. And also thinking about, am I using the right image format? So things like SVG can be delivered in a much, much smaller container. And they're scale invariant, so they work on high resolution devices. You can do animations.
Hmm.
We've seen a resurgence of GIF files, or I guess GIF files, on the web over the
Yeah.
last couple of years, and those are terrible
Yeah.
in terms of actual file size.
Hmm.
They work across browsers, all browsers, which is great, but they're megabytes upon megabytes,
Hmm.
and the same content delivered as an actual video inside of a video tag is like 10 to 20 times smaller.
Oh wow, I actually did not realize that.
Yeah.
For,
So
for
actually,
the same video, the same loop playback would be 10 to 20 times smaller if it wasn't in a GIF.
right, because
Wow.
so GIF takes each frame individually and compresses each frame, and there's nothing that there's no magic that happens between the frames. But if you think about it, an animation is just a lot of back-to-back frames, which are very similar. So movie compressors use that fact to compress each particular frame and also share information between each frame such that they don't have to re-encode each frame.
I see.
And because of that, movie files are a lot smaller than your GIF files, and
Wow.
that's a huge savings. So actually, I think I believe Twitter does this. If you upload a GIF file, sorry, I still call it GIF. I can't change the habit. If you upload a GIF file, they will actually transcode it to MP4 and serve it as an MP4.
Mhm.
So to you, it may not seem like anything has happened, but under the hood, because of the savings, they actually do this on your behalf.
I mentioned Linux Academy at the beginning of the episode, and I want to explain how their training works. They have about 2,000 videos, but they're not just a video library. As you watch videos, instead of just taking notes, you can actually practice alongside on real machines. That's right, you get access to 6 different machines that you can SSH into at no extra cost, and at your own convenience. If you're stuck on something, that's not a problem. You can just post in the vibrant community and instructors will jump in to help you. All of this, unlimited access for just $22 a month. This is a great way for you to learn, and it could also be a really good gift for someone you know. Get your 24% discount now at scallyco.com/Linux Academy. That's scallyco.com/Linux Academy. When looking at, we mentioned PageSpeed and there's also the DevTools, which we're going to cover in just a little bit. But when we're looking at these kinds of metrics, a lot of people talk about the time to first byte, right?
Mhm.
Is that really still an important metric?
It is absolutely depending on your context, right? So to your point earlier, with a bad shared host where for some reason or another the request comes to the server and the server takes just a really, really long time to give back the bytes
Mm-hmm.
to the browser, right? So that could be a slow app server, a slow database, a combination of both, or maybe your code is just inefficient as generating the HTML. And obviously, the longer you wait, the worse off the user, right? Because you want to give back the HTML bytes to the browser as soon as possible. So the request comes in, and ideally, it's a cached resource that is right there. The server can stream it back, and the browser can start parsing it and start displaying something on the screen.
Mm-hmm.
Sorry. So when we say making the page load fast, we don't mean we don't have to display the whole page all at once, right? In fact, all the browsers are built around progressive rendering, where as soon as we have some HTML, we start parsing it, and we try to do our best to start displaying something to the user, even while other things are loading. So the text is there, the images come in later, and all the rest. So we want to optimize that experience. And time to first byte is very important, right? So there's a huge difference between the browser sending a request and then you waiting, I don't know, 5 seconds to get some HTML, and immediately getting back some HTML bytes that we can start parsing. So it definitely matters.
Okay.
But the question is how much of an impact is it going to have relative to other things that you need to fix on your page?
So I sent you 2 pictures. Did you get a chance to see those about the timeline, the DevTools timeline?
I think I did.
Where there was, it just, for example, I'll explain it, but I'll also put the image up on the video so people can see it, and in the description below the video as well, where I basically just have a network trace, the network timeline of loadingscaleyourcode.com, and the first one is going to be the HTML document, of course, where it shows you that there's a green bar with the waiting time to first byte. For my case, or in this case, it was 141 milliseconds. And then there's also the content download, which was about 3 milliseconds. And then you can click on there and it explains it, and it shows you a total of all the milliseconds. Now, that's the waiting time. That's the time, in parentheses, it says time to first byte. So am I understanding correctly if I say that that's basically the browser waiting for the server to send all the responses back and all those bytes being transferred via the wire? Is that right?
Pretty much. So what the time to first byte captures is the browser has sent the request, and now we're just sitting there idling because we need something to start chewing on, right? To process and start make the page visible.
Okay.
And the time to first byte is just when did we actually receive the first response byte? So this is like your HTTP headers and some of the HTML. In your case, in this particular image, then we also spent another couple of milliseconds receiving the bytes. So I'm guessing the page was small enough such that it fit into just this one push, one transfer, one round trip.
That's talking about the content download?
Right.
I see. Okay. So the waiting time is waiting for my server to send the response back.
Not just for your server, but also just for the network, right? So the browser sends a request. It traverses some number of hops between you, depending on what kind of connectivity you have, down to your server. Your server generates the response, starts sending it back. We make it all the way back, and that's the 140 milliseconds kind of captures that end-to-end round trip. So 140 milliseconds is actually pretty good because you factored in the full path there and back, plus the actual server generating the response.
So if you want to lower this number, which sounds like it's quite important really, you want to have a CDN that's closer to the end user. That way you minimize the network distance, and you also want the server to generate a faster response, right?
Right. So ideally, you would serve this response from as close to the user as possible, which is where the CDN comes in. Okay. And ideally, it would also be cached at the CDN such that the CDN does not even have to talk to your server.
Right. How can you measure what part is doing or is taking how much time? Like, for example, how could I measure that my server is taking X amount of milliseconds to respond? How could I measure that the trip on the wire took X amount of time? Can we do that? Is that possible?
You can. So that's actually the navigation timing API that was developed at the W3C Web Perf group. So there's navigation timing and resource timing, which exposes the same data that you're showing here to script. Okay. So, for example, you can use something like Google Analytics or New Relic or SOSTA, one of these performance providers. You can drop in the script on your page. They will collect this data on your behalf and aggregate it and show you the quantiles, the medians, and all the rest for your response times. And then you can figure out, like, is it my server that's being slow? Mm-hmm. Is it because the types of users that are visiting my site are just on slow networks and they have this long RTT? Mm-hmm. Because then that tells you something else, right? Like, if I have a lot of users on slow networks, well, maybe I really ought to reconsider the types of images or how much content I'm shipping, such that I can reduce it and improve their experience.
Okay, and then if that content download is too long, and I don't know how you quantify what too long is, but let's say it takes, I don't know, half a second to download all the content, which is probably exaggerated, but anyway, that's because you're serving too much content at the same time, right? Maybe you could split that up into two different requests where you're showing only the above the fold content, and then you're fetching the rest of the content later on. Is that right?
Yeah, so ideally, the recommendation that we give is that you should aim to make the page visible within 1 second.
Okay.
Within 1 second, users tend to treat the experience of loading within 1 second as almost instantaneous, right? Mm-hmm. Like, they acknowledge that it's a fairly big transition, so they're willing to give more time. Once the page is interactive, you should respond within 100 milliseconds to all the user inputs, so like to acknowledge their input. But the initial load is 1,000 milliseconds, and that's not an easy target to hit, to be honest, because you said 500 milliseconds may be too long, but actually in practice that's not that much time if you consider that you need to set up the TCP connection and other things and actually download the content. And don't forget that on a slower mobile connection, you don't have a lot of bandwidth. On a lower generation 3G and even 2G networks, which are still very much prevalent in many parts of the world, you're seeing like hundreds of kilobits of bandwidth, right? And to download a 100 kilobyte file, it'll literally take them over a second.
Wow. Yeah, and see, I've got 60 megabytes here, so the results that I'm seeing and that you guys are seeing on this image are very skewed to my network and my kind of connection. Whereas if you're loading it on another kind of network or in a different country or in a different device, then you're probably going to see some very different numbers. And that's the tricky part, isn't it?
Yeah, so I actually have, I guess, two tips, or one tip and one observation. The one tip is, if you haven't already, try the network emulation in DevTools. So if you go into your net panel, you can actually enable effectively network shaping, where you can select like 2G, 3G, or something else, and just try and load your page and a few other pages with that on. And you will very quickly feel the pain of it. And just observe how slow it all actually goes, and you'll be able to see it in a waterfall too. And that's one. And the other, I guess, observation is within Google, I think within the last year, I think it's been around for about a year, we've actually, so of course we have Wi-Fi, right? Let's just like blanket it around all of our offices. But we also added emulated 2G and 3G Wi-Fi access points, so you can just connect to this kind of poor quality Wi-Fi. And we encourage developers to connect to that and just start, try and use it. Like, try using the web on 2G or 3G shaped network to understand the pain. Right? Because sometimes you don't have the luxury of having your DevTools open and other things. And it's really hard to test these sorts of things. And I know that from talking to lots of developers, this was an eye-opener for them, because it's easy. You just switch to a different network, and all of a sudden, something that was previously very distant, right? It's like, networks are slow. It's like, yes, of course they're slow, but mine's fast, so it's all good. And then you actually try to experience it, and you go, okay, fine. All right, like I get it. I need to fix my application.
So would you actually recommend that people take once the application is built, maybe take this kind of slower network approach, purposefully create a slow network using DevTools, and use that to debug what is slow on your page? Do you think that's a pretty good approach to take, instead of just looking at the fast speeds on a faster network?
Yeah, absolutely. If you're not already using some sort of kind of emulation to test, at least get a feel for how your pages behave on these slower networks, then that's definitely something you're going to benefit from. I don't think this is something that you should be doing at the very end. It's like, I'm ready to ship, and now let me test it. Right? It's just, performance is like security. You can't sprinkle it on after the fact. You kind of have to bake it in from the beginning. So test it as you build it. And I think different teams have different approaches. So for example, like at Google, we have this network that anybody can connect to at any time. I recently was reading an article where Facebook, I think they've instituted like 2G Tuesdays or something like that, where they encourage all the developers on a Tuesday to shift to this kind of same idea of 2G network. But at least once a week, everybody's using it, such that it becomes more ingrained that you have to, this is not something you can ignore. Right? Like, there's so many users using these slow networks, and we have to optimize for it.
But it's so easy to ignore when you're on deadlines and you're getting paid by clients to have this product shipped out on deadlines. Sometimes it's very hard for developers to take that kind of performance first approach, because they're just trying to ship and stay on deadlines. So that's a fine line to walk, for sure.
It is, absolutely. And performance is a feature, just like anything else, right? I always advocate for treating performance as a feature. So just as you would think about adding some new whiz-bang feature to your product, performance is just one of those things. And performance, like any other feature, will affect your success rate, your engagement, your conversions, and other things, right? So one of the great benefits of the navigation timing API, the resource timing API, and other APIs that are available in the browser to get this real user performance data is that you can use that data, you can grab it, and you can correlate it to your other conversion data. So things like, oops, the lights just went out here.
Yeah, it got a little bit
darker. So you can actually correlate it against your conversion metrics. So you can actually say that, look, I see that my users are running slower here because of networks or some other conditions. Let me look at the engagement, right? And we've study after study shows, and you should validate it on your own case. There goes the other light. That when the performance is lower, your conversions are lower. And that becomes a much more compelling argument, right? Because then you say, well, yes, we can ship this new feature. This will add more kilobytes and more things. Or we should focus on fixing performance because we're seeing this huge difference between users on fast networks and users on slow networks.
There was a research done by Amazon on that a few years back where they showed such a drastic change in revenue depending on just from 1 second of extra load time, hundreds of millions if I'm not mistaken. So that was done a few years back, and it seems like people are getting less and less patient when it comes to loading pages. So I could see that being even worse nowadays, but who knows? Maybe they've done some more recent research studies that I'll have to check.
Yeah, there are many case studies from many organizations. Google has shared data before, Amazon, eBay, and all the rest. One thing I would caution against is there's no one number that is like true for everybody, where you say 1 second will make you millions or break millions sort of thing. It really depends on your context. But one thing that is consistent is that performance does matter. Like it's a contributing factor. The question is how much, and that's where you need to measure, right? I talk to a lot of developers who get really excited about performance, which is great. This is exactly what I want them to do. But sometimes they fail to connect the performance benefits to the actual bottom line, or something that would allow them to sustain that effort, that performance, because they'll make site fast, but then they start adding new things and performance regresses. And because they couldn't quantify the benefits, like they can't sell it to their development team, to others in their team, to their managers that, hey, I'm passionate about performance. I want to focus some of my time on it, and this is why.
So let's talk about that. Let's talk about the things that really add or slow down the time it takes for the page to render properly, right? There are certain things that you can add on a page depending on if you're asynchronous loading JavaScript, or how CSS is render blocking, is JavaScript blocking the parser, things like that. So let's talk about some of those things. And I think that my second image that I sent you here might illustrate some of those things where, I don't know if you have that one pulled up or not, but it's the second image I sent you where it shows more of the timeline. I didn't hover over that specific document loading, but you have that first scaleyourcode.com get request that is 145 milliseconds, and after that it requests the first CSS file, which is main.css. Now there's a blank amount of time between the two. Why is that? Why is it not loading the file faster?
That's a great question. I don't know right off the bat, because we need to dig in and actually look at it. My guess is if you were to capture that same trace or the same page with the timeline view, where you're also seeing where the time is spent between JavaScript and other things, you'll probably find that this is the time when we're parsing the HTML, we're doing some background work, or maybe we're blocked on making the request because there's another blocking request. So this is where we get to the conversation about optimizing the critical path.
Yeah.
Right? It's the kind of that sequence of steps that the browser needs to take to get the HTML, construct a DOM, get the style information such that we know how to style the page, and then execute any JavaScript that is critical, that is in that critical path, and then paint that content to the screen, right? And CSS is obviously critical for all of this stuff. Some of the JavaScript is definitely not, but many sites unintentionally put it into the critical path without recognizing that it doesn't need to be there. So there's lots of room for improvement on many sites.
So you need to have the DOM, or I'm sorry, the HTML to create the DOM, which is going to be the first thing in your critical render path. I mean, you can't get rid of that unless you don't use HTML. And then after that, you have the CSS, which turns into the CSS OM, right?
Mm-hmm.
And then after that, depending on how you load the JavaScript, it may be added in there, which is why it would be render blocking, right?
Mm-hmm.
Because
that's right.
the browser assumes that you're loading it to change the DOM, right?
Mm-hmm.
Okay, so after that, it creates, correct me if I'm wrong here, I'm probably missing a few steps, but after that, it's going to create the render tree, and then it's going to paint it. So how do you make sure that the JavaScript doesn't slow down that process?
So as you mentioned, by default, if you include the script tag, and this is mostly due to kind of the history of how the web has evolved. When you put in a script tag in your HTML, due to the nature of script, the script can do arbitrary things, right? It can reach higher into the DOM and change some attributes. It can completely rewrite everything that's after it. So because of that, when we encounter a script tag, we say, well, we have no idea. When I say we mean the browser, right? Mm-hmm. The browser says, look, I have no idea what's going to happen next because this script can do arbitrary things on the page and to the page. So I will need to stop, wait to fetch the script if it's an external script, if it's not an inline script. Then I need to parse it, then I need to execute it. And after that, I can proceed. So the one escape clause that you have here is you can make scripts async, or you can add the async tag on the script if it's an external script. And what that tells the browser is that it effectively promises that, look, this script is not going to manipulate the DOM. So what you can do is you can start fetching this thing and execute it once it's ready, but you don't need to block. You can continue parsing the HTML, you can do your layout, and you can actually render content to the screen. So this is ideal for things like analytics and other things which don't affect the rendering of the page. They don't need some particular ordering of how the scripts are loaded. And if you do, then there's more advanced patterns that you can implement to make sure that the scripts are not in your critical path, such that you can get something visible on the screen.
So you don't need to put these scripts at the bottom of the page anymore. You can have them in the head tag. All you have to do is put an async tag.
Right, yeah.
In fact, if you put them at the bottom of the page, then the browser is going to start loading them later, right? So you probably want to have them in the head tag.
Mm-hmm.
Now, what about if you have a dependency? Say, for example, you're using jQuery on the site, and then the other script that you're loading right after that depends on having jQuery to work properly. Then you can't use async on jQuery, can you?
It depends. It depends on your application. So this is where we'd really have to dig in and figure out what are you using jQuery for, right? So if you're using, like, if your script is actually constructing the page and has some behaviors that are absolutely critical when the page becomes visible, then you may need to somehow block the rendering, and that in itself is a bad pattern, right? But you may need to block rendering until the scripts are available, all of their dependencies are available, and all the rest. Frequently, what I see is that the page itself, even if you just exclude jQuery and kind of the dependencies that you're describing, is perfectly functional from a user's perspective, in the sense that I see the content, I can start reading it, I can start interpreting it, but certain actions may not be yet available. Like if I try to tap on something, like I'm not going to get the tooltip or something, right?
Okay.
And I think of that as progressive enhancement. Like I think in many cases you can defer and make the stuff async without blocking rendering, where the user can start consuming the content, and then you enhance it with these additional capabilities. Now, this won't work for every single application, but I think as a rule of thumb, this is an underused technique or strategy for loading the scripts.
And the difference between async and defer is that async will start loading before the page has finished to load, but it's not going to be in the order, right? And then defer, on the other hand, is going to retain that order, but it's going to start downloading a little bit later in the process, right?
Yeah, this is where we get into a little bit of platform archaeology. So defer was introduced back in the day by the IE team, and it's actually, technically it's now a deprecated tag. And really you should be using async. And defer also had a few implementation bugs back in the day, which makes it make it kind of hard to work with. But that said, if you need to target old browsers like IE6 and IE7, async is not available in those browsers because async was defined later, but you can still use defer, this defer keyword, to get some performance benefits out of it. So in practice, you'll see some people use both async and defer, and it's mostly just to get that coverage of the older browsers.
How can you measure the difference that async does? Say, for example, you're not using async and you want to see if it does make a huge difference or not. How do you measure that?
That's a great question. So this is where we get into a discussion of visual progress, right? So we keep kind of alluding to this, get something visible on the screen. And we have not had a great set of tools to actually measure that. So the best tool that we've had for a long time is the web page test film strip, where if you're not familiar with web page test, it's webpagetest.org. You can come there, kind of similar to PageSpeed Insights. You type in a URL, you press start the run, and it can capture a video. It basically takes a video of the page rendering frame by frame and then shows you visual progress. So you can set up a test where you have the before and the after, and you can actually do a side by side and see how quickly it renders. Now, more recently in DevTools, we've actually added the timeline view and the screenshot view, which does something very, very similar. So if you open your timeline and you enable the screenshot option and you just reload the page, you'll see that it captures previews of the screenshots, which allow you to gauge where the page was at like 100 milliseconds versus 200 versus 300. So this is where you could take the base page with a synchronous blocking script, switch your network emulation to like a slightly slower network such that you're not fetching it from localhost at blazing speeds, and compare the film strips. And I think you will see a dramatic difference.
So this is a really, really powerful tool. I'm not sure if you've personally worked on those kinds of that part of the DevTools or not, but the team that's behind it has done an incredible job. I will say that. So thank you guys a lot for helping us out with that kind of stuff. But it can be a little bit intimidating because there is quite a bit going on, and a lot of times there's all these events being fired. You're not exactly sure what they mean. Sometimes they don't look right, but you don't know how to fix it. How do you get started with that? How do you understand how these things work?
Good question. It's definitely something that's on the radar for the developer tools team because we know that. So historically, let's backtrack a little bit. Historically, we have actually not had great tooling for especially rendering performance, right? Over the course of the last year and a half, we've added a lot where you can actually see when the style of calculations are happening, how it interacts with JavaScript, how the network interacts with all these things. And actually, the big change that I think if you've been using DevTools that you've noticed in the last 6 months is And you get the benefit of smaller requests. You can multiplex requests. You can prioritize requests. It allows the server to be much smarter in how it responds with the data. And it allows the server more flexibility in how it sends the response, so things like server push. So the combination of all those three allows for some pretty nice wins in some cases.
Then do we still need to concatenate files, to minify them, and to do all these other tricks that we have been doing as developers to speed things up?
Yes and no. So minify, yes, right? So minification is, in effect, content-aware compression, where, let me give you an example. Let's say I have a JavaScript file, and because I'm a good developer, I've put a lot of comments in it, right, such that my fellow developers can look at it and understand what I'm doing. Now, it turns out that comments don't affect running code. Hopefully they don't. So there's no reason to ship comments, right, to production. But those comments do take bytes. Like if you actually take, since we've used jQuery as an example, jQuery has extensive documentation. Mm-hmm. And if you look at the original version with comments and then the minified version, the biggest difference is they strip out the comments. And turns out that's like 50 kilobytes of data compressed, right? Because they have a lot of comments in there.
Yeah.
So that's an example of minification, even before we get into kind of more interesting and advanced use cases like shortening variable names and doing other stuff. Just removing the comments from jQuery is like saving tens of kilobytes. So minification still makes perfect sense. Things like concatenation starts to become more interesting, where the short answer is mostly not, right? So in the past, we built a lot of infrastructure and developed best practices for concatenate all your files into one script.js or one style.css. And that has its downsides too, as it turns out. Like say you have jQuery and your code and you put them together, then you update your code. Now you have to ship jQuery again, right? Even though jQuery hasn't changed. So that's not great. So you want to unbundle those. But then if you unbundle them, you run into the same problem of we can fetch at most 6 things at a time, which may or may not be a problem for your particular application. So there's always this trade-off, and you're not quite sure what to do. HTTP2 changes that in the sense that it removes this bottleneck of 6 requests. You can actually send hundreds of parallel requests. There's no issue with that. Now, does it make sense to ship like 101 kilobyte JavaScript files? No, probably not, right? Because that's like, the question is, can you get any benefit from bundling into larger buckets? Like if you know that 2 components are always used together, you can still put them together, unless there's going to be high churn in one of them. So you don't need concatenation and bundling as like a must-have with HTTP2.
Excellent. I definitely have some homework to do after listening to this interview, or after conducting the interview, I should say, but there are quite a few things that I can already think about that I could optimize on my own websites or web apps, including enabling HTTP2. That's going to make such a big difference. So I'm going to have to do that as soon as possible. Ilya, I really appreciate your time, and thanks a lot for answering these questions for us. I got one more question for you. What is something that you're working on right now that is extremely exciting to you?
Well, okay. The hard part is picking just one.
Yeah, I was afraid you'd say that.
Let's see. So there's a number of APIs that we're working through, I should say, with the Web Performance Working Group that I think will be really, really exciting. One, and this actually comes back to kind of that visibility use case. One is the intersection observer API, which sounds kind of very abstract, but the idea here is there are many cases where you want to know, or the developer wants to know, when a particular element on the page is coming into the viewport, visible within the viewport, or is about to. So think about like infinite scrolling, analytics, and other use cases. And this is a very, very common requirement for many applications. And it turns out that it's very expensive to implement well in terms of how much code you need to add, how much infrastructure you need to add, and overhead that it adds to the actual like scrolling. So this is why you try to scroll and like it's kind of janky. Like you can tell that it's skipping, right? It's oftentimes due to these scripts running in the background. So Intersection Observer is an API that allows you to just subscribe to notifications for like this. I want to know when this element comes into viewport, and that will make a lot of things much easier, and the performance will be much better. So that's really exciting to me.
Excellent. Well, thanks a lot, Ilya. I really appreciate it. If people want to reach out to you, how do you recommend they do that?
The best place is to find me on igbita.com, and then you can find all the links there.
Perfect. Thank you so much. I really appreciate it. Leave a comment to thank Ilya for his time and answering the questions. Thank you all for watching.